Yeah, good morning, everybody. This is Dr. Venkat Rayapati. I'm the founder of SAI Technology. I will be presenting LTE mobile software defined networks and applications pertaining to LTE networks. The second foil, I'll just to be summarizing what we will be presenting it today in terms of the mobile software defined networks and how their applicability to LTE mobile network implementation and challenges. I'll go through the radio access network, how the importance for the radio access networks, and we will also apply the mobile software defined network and implementation process for the LTE RAN, and the RAN network migration to the cloud RAN, and similarly EPC migration to virtual EPC. Then we will provide a complete live demo of the LTE cloud RAN and virtual EPC, and then finally we'll provide LTE mobile SDN applications and conclusion in this presentation. Then I'll just move to the next foil. This foil mainly will be summarizing LTE mobile software defined networks and applications. What are the specific challenges? Today in the industry there is a software defined networks which is specifically addresses the routers and switches. There is no framework exists for mobile software defined networks. In this case, we will be addressing the mobile core components like the RAN, packet core, and also basically that with respect to routing, security, configuration, provisioning engines. And we also address how this applicability to mobile virtual operators, and also we deal with the licensed spectrum and unlicensed spectrum of LTE and applicability. In this presentation specifically we address the software defined network, mobile software defined network framework for the radio, packet core, and all the other components. We also provide LTE RAN and virtualized EPC core, how the design flow and methodologies, and we will address in terms of the network virtualizations function and the dependencies, and we move into the case study implementation for LTE LTE advanced networks and recommendations. I'll be moving to the next file. Specifically here we are going to be addressing the radio access network. The radio access network is the critical core component of the cellular infrastructure, which comprises of base stations, remote radio heads, and remote radio units, and so on and so forth. Here what we are trying to address, there are two parts of the network. One is the LTE core network. What it does is enabling all the basically authentication, security, in terms of SLA enforcement, QoS, and all the mobility aspects. Then it gets into the radio access network. The radio access network specifically provides how to use and manage the limited spectrum to establish the connectivity, and follows the radio resource management in terms of the handovers, in terms of the interference control, load balancing, and between different cells, how the load has been distributed, and so on and so forth. So in this case the RAN has to be very specific. This is a major element in the network. I will move to the next file. Specifically, what are the RAN core functions? The RAN core functions are specifically, first the RAN needs to establish a connectivity. The base station needs to establish a connectivity with the cell phone. Now in this process we analyze the signal strengths and RSSI and CINR values based on the modes of implementation, either FDD or TDD, time division modes. We will be operating, particularly the demonstrations all will be shown here, FDD mode, frequency division multiple access, that has been implemented by Verizon and AT&T and so on and so forth. So here what we have shown is, in this case, in order to establish this connectivity, we have shown the time and frequency equations, the resource blocks, how they will be allocated, then moving to the different power levels, how the resource blocks will be handling the process. So I'll just move into the process of the next step. When there is a data processing, all that stuff will be done through all the elements the radio resource management will be supporting. In this case, all the call control admission control, traffic management, in terms of radio barrier management, all the load balancing establishment, and so on and so forth, inter-RAD, intra-RAD. So we will be moving into the next foil, specifically dealing with respect to the mobile SDN application to mobile virtual network operator. So in this case, specifically what we are going to address the time constraints of specifically that how the mobile virtual operator can benefit utilizing the mobile SDN concepts and the framework all the way from their data path, the control path, and the mobile applications and services. One of the significant portion of the mobile SDN today will bring disruptive transition to the mobile networks, and also the current open flow model is not sufficient to address the given mobile virtual networks. I would like to really move forward with the next file, specifically that how the mobile SDN addresses the core components of the RAN, that's basically soft RAN and soft packet core and soft routing security and provisioning management control elements. Now in this case, specifically that we will be moving into the process of all the protocols compliance aspects, protocol software, each cell implementational aspects of the details. Once we are implemented as per the 3GPP full compliant software, and that will be moved into the next level, that is mainly the RAN design migration into the cloud, which we can implement on any generic servers. Now in this case, the two key points which we want to share, all the building blocks shown on the right hand side of this file will be able to move into the cloud with much more flexibility in terms of managing latency control, QoS management, and also application level deployment activities. So I would like to move forward with the next file, specifically that here in the mobile SDN point of view, the architecture for the LTE RAN implementation. The three core components here is the control plane, which will provide all the control messages, the data plane, which will be able to provide both the transmit receive type of the data path aspects of it, and this will be also enables the downlink and uplink data throughput. The operating system which will be able to provide the interprocessor communication flow aspect of it, so that way it enables that very significant the data path mechanism implementation. So to ensure the end-to-end latencies and to ensure all the management aspects of it, to provide for every base station. Here layer 1 to layer 3, the baseband processing, layer 1, layer 2, PDCP, RLC, RRC, MAC layers, and then you have radio resource controller and OEM. All these aspects will be implemented into this SDN architecture. So this SDN architecture has a significant impact with respect to next generation networks like LTE advanced or 5G networks and so on and so forth. So we move into the next file. Here the mobile SDN based the LTE RAN design aspects. The design for each base station point of view. Traditionally all the base stations are hardwareized implementations. Today we are moving everything in software based implementations. This further applying certain type of virtualization techniques, caching mechanisms, and memory management techniques as an efficient way of implementing and processing this stuff. So for specifically that in this case, what we are trying to really address the process of specifically that we are trying to apply the radio resource control algorithms, and also the network operator or service provider input parameters to control the data applications like voice data, video applications, and so on and so forth, and enforcing the QoS and priority mechanisms implementation, even though at the server software level implementation, to ensure all this spec level will be met. So I just would like to move into the LTE RAN controller implementation, applying the mobile SDN principles. Here the RAN controller has about 4 critical pieces. One particular component which does about basically that in terms of the spectral map, alignment aspect, that's mainly dealing the frequency division domain and time domain aspects. Then you have the processing, data processing, signal processing aspects, which will be dealing with all the amount of throughput, that in terms of the QoS, in terms of the flow control mechanisms that will be supported. Then you have the other element which is specific to the operator, which is SLA enforcement, service level agreement enforcement, which has direct mapping dependency with the QoS parameters. In this case, the radio resource management algorithms, which will be able to provide with whatever the modes of operation, either FTD or TDD modes of operation, with respect to the standard industry defined radio interface standards like CIPRI interface or OBSI interface or femtoform interfaces. All that stuff will be supported in the mobile SDN controller. I would like to move into the next file, specifically to address network functions virtualization and their dependencies to Cloud RAN and particularly virtual EPC and so on and so forth. In this case, particularly today, all the packet cores are implemented in terms of as an appliance-based devices. Each appliance device basically that people are selling as an appliances, Cisco routers as an example, in terms of the core, packet core, gateways. All these are appliance-based sales. Now, what we are trying to, the migration path here from an appliance concept to all the way software based, wherever we want to move without any constraints, apply more efficiencies, as a common server platforms, which are either x86 or ARM based platforms. We can run the same applications with virtualization implementation. Here we apply all the dynamic resource management and all the functionality with the implementational aspects related to virtual EPC cores. So I would like to move forward with respect to the LTE virtualized packet core implementation aspect. Here I just want to share 3 key attributes. The enhanced packet core has 3 components. One is the packet data gateways. The packet data gateway, it will provide all the dependencies between the 3G, 4G, basically that in terms of the Wi-Fi, non-cellular and cellular network infrastructures. The serving gateway, which will be able to provide all the specific policy enforcements in terms of the SLA enforcement, the pricing and billing constraints. Then you have the HSS, that's the home subscriber server, which will be able to provide the connection establishment, and you have the AAA and diameter servers, which will be able to ensure the security between the cellular infrastructure and non-cellular infrastructure. Then the EPC with the advantages of moving into the next level integration, which comes into the IMS integration. So we will be moving forward with respect to a live demo based on what we have explained so far. With respect to here, we are trying to perform the live demo using LTE and LTE advanced implementations based on the Cloud RAN and virtual EPC cores. So what we have in this demo, there are 2 key highlights. One, everything was implemented as a soft EPC or soft RAN implementations. Then we have migrated this into virtual EPC core, that's the core network for the LTE, and similarly we moved the soft RAN into implementation on a cloud-based implementations. Again, we are fully compliant with the 3GPP standards and also operator-specific standards, which have been fully implemented here in order to support from an end-to-end applications all the latency, round-trip time, requirements. Now we would like to move into the process of demonstrating the applications. If you just have, we do support completely roaming and handoff in this network and all the radio parameters, and basically that with respect to establishing the connectivity for between the base stations. Each base station is considered as a cell site. When a user is moving from one site location to the other location, whichever the base station can offer to provide the strongest signal strength, that will be moved into that process. So I would like to move into the demonstration, the next flow. Here what we are providing is you have the complete mobile cloud RAN implemented, fully compliant with release 9 and release 10. Similarly, virtual enhanced packet core is fully implemented, fully supportive, interoperable with respect to all the existing system suppliers. Now the demo will demonstrate multiple video channels, video calls, voice calls, and data calls going through. It's a fully scalable network, can be applied to any type of operator, network operator applications. And it is customizable because it's being in the cloud, and some of the applications have full scalability aspects. So this is a live network implementation. Interoperability with respect to some of the operators and other customers have been supported today. So we will move into that, basically in terms of the network operators, why they need in terms of this type of SDN and the applications which are moving into small cells as they start deployment of the networks. Definitely there are applications which are converging into the enterprise applications, and also several verticals which will be really required in terms of moving the mobile SDN applications with the LTE network. Here we are solving the problems of bandwidth, latency, QoS, scalability and flexibility, agility of the network. Here we would like to really address two fundamental applications for the cloud-based RANs. The cloud RAN is flexible, fully scalable to support any type of data growth traffic. So in this case we are able to support existing, for example, converged and fixed networks for rural areas or urban populations. And in this case the applications which are like video, social media applications, Netflix, and some of the cable applications, enterprise applications, which will be able to implement it using the same mobile cloud architecture. Here as an example shown, a sports stadium, a business district where several enterprise businesses are located. Similarly for the downtown where the populated crowd will be utilizing this type of network in real life application. So we move into the mobile SDN based cloud application. As we said, these applications are scalable for cable operators, service providers, even ISPs, even with the transportation networks, mission-to-mission networks, and healthcare vertical network application communication side, and mobile virtual private networks, which are growth in particularly US side. And there is a lot of opportunities which are evolving for the next generation network evolution. Here this particular diagram which explains the key attributes of either you are applying centralized architecture versus the distributed architecture. Now in this case how the integration is going to evolve for the future networks, that has been demonstrated in this file. So we would like to take the case study and apply specifically that where you have the legacy networks 2G, 3G, where you have the 4G networks and the LTE advanced and 5G which are coming through. In this case specifically that we are trying to provide that flexibility of applying cloud RAN and mobile virtual networks, and here they will provide very significant advantages for the developing countries to reduce significant capex investments, and also they are flexible, agile and scalable for different applications on demand, and they are also able to support the legacy backward compatibility aspect which will be able to support in terms of in a highly reliable, secure, and cost-effective communications implementation path. So this summarizes particularly that these networks are backward compatible and able to support for further forward development aspect for future growth. So I would like to conclude in terms of my presentation that SAI has demonstrated one of the world's first 4G mobile cloud and virtual EPC using the mobile SDN concepts, because today there is no existing framework for the mobile SDN. So we have formulated the basic foundational process which will be able to utilize both the open flow and non-open flow implementation of the architectures for the SDN, mobile SDN. And specifically that here we are also applying network functions virtualization aspect to enable the virtual EPC. So in this case, all the critical components of the LTE network, which is basically that which are software based, the soft RAN, which is basically cloud RAN, and the other part is virtual packet core, and the last part which is basically that virtual routing, security, management, control, configuration, provisioning elements of the network. So which will be able to bring together a combined mobile SDN network for the real world applications. The applications will be, there are significant advantages. By applying the mobile SDN, the network operators can expand their network on basically that either virtualized implementation or cloud-based implementation aspects. The second thing is these networks are flexible, they're scalable, they're reliable, and particularly mobile virtual network operators or service providers or ISPs or MTM networks or power grid networks and so on and so forth. They can utilize the same infrastructure framework and apply in a very cost-effective manner. The LTE LTE advanced 5G networks all will be developed for the next 20 years based on the mobile SDN infrastructure. They can be applied for private networks, public networks, and also the tier 1 operator networks and so on and so forth. Now here basically this type of network will enable very cost effective solution and fully scalable, highly reliable, dependable solution. This is the direction industry is set to go for future growth for the mobile network industry, specific to the applications which are demanding like mobile video and data and voice applications, and also the social media applications driving the growth.